Hello everyone. Uh, In this lecture, we will be doing some numerical of Turing machine. And last lecture, we have already discussed that what are the tuples and how left move, right move, how we write on the tape. Everything we have checked in the done in the last lecture. So, in this lecture, we will be doing some numerical of Turing machines, how this is accepted. Suppose any not if not a context free language, how we will design Turing machines. If a context free language is there, how to design a regular Turing machine. If a regular language is there, how to design in Turing machines. So, different language we will be doing here. So, here all say already we have seen it, we have 7 tuples that already we have seen in the last lecture. So, no need to go again. So, we have to do some numerical. So, let us first take an example. L is a to the power n and b and this is n greater than equal to 0. So, this is a language is given, this is a language given. For this we have to design a Turing machine, we have to design a Turing machines. So, you see this language is a regular language, we can have finite automata also, we can have also push down automata, also we can have push down automata. So, here you can think about the finite automata, here minimum string length is 2, that is 2b. So, here what you have to do, same thing here you have to do like the previous class I did one example. This is Q0. If any regular language is given, you just read it and move right, and when you will find the blank and go to the final state. So, here this is A R, then we have B R, then we have another B, this is Q2 Q1, then this is B and B R B, this is B R, then we have to go to the another state, this is B R. So, B R, then after we have Q2. So, here Q2, when we will find here blank B R, go to QF, QF is our accepted state. So, this is the, you see here all the string end with 2b is accepted, but before that it should be all A, it should be all A. All the string 2b is not there, because before only 2b is there, end with 2b is accepted, and before 2b all should be A. So, here is the, you see the language, what are the minimum B, the strings are strings, what are the strings here B, then A B, then A B, like that it will be accepted. So, this is the Turing machine for this language, because this language is regular, just you have to read all the input and move right. So, take a string here, here we have to take a string, a small string, which check either this is accepted or not. So, we will take here another string is B, only B is accepted or not, B should be accepted by this diagram. So, now Q0 point to A, Q0 point to B. So, first input is B, Q0 point to B. So, we have taken a string that is B, we have to take a string B. So, now after that what will be there? You see your tape will be, this is B and move to, this is Q1, this is right. here we are using the transition which transition you are using, B to BR, means your tape input will be remain same and only move right. Then after you see, then after here is the, then after you have to go to the, this is B and this is B and this is blank and this is blank and Q2 now point to blank. So, when Q2 point to blank, you can see this is go to final state. Now, you have this is B and B and this is blank and this is QF. QF. So, now this is also, this is a blank. So, now this way your string is accepted. So, here we have taken a language and we have designed the push down automata, Turing machine. Then we have taken the strings and how this tape is in moving, our head is moving, first Q0B, then Q1B, then Q2 blank, then Q2 blank, we can go to the final states. So, this is one example of regular language, how this is accepted, by the Turing machine. So, if regular language is given, it is very easy to design the Turing machine, just the concept of finite automata. If you have finite automata, you know the finite automata concept very clearly, then easily you can do the Turing machine of a regular language. Just go by right, move the right and no need to write anything on the tape. When you will find the blank and go to the final state. So, now we will take another example. So, suppose take an example, this is L, A to the power n and B to the power n and n is greater than equal to 1. So, already we know this language is not regular, this is a context free language. You will check that if you will use the pumping lemma to prove for the regular language is not regular, and you can prove that language is not regular and this is a context free language. Also, if you will check the pumping lemma of context free language, this will be satisfy all the three properties of the pumping lemma of in context free language. So, this is a context free language, we can have push down automata for this, but how we have to design the Turing machine for this? This is important, how we will design a Turing machine for this. So, let us take, I will start the diagram. So, this is the Q0. What is the concept here? You have to first remove one A from replace some tape input. Suppose A will be replaced by X and B will be replaced by Y. I have taken two symbols in tape, extra symbols. A is replaced by, for A replaced by X, B replaced by Y, So, what you have to do? We have to replace what you have to do? Replace one A, then replace one B, again come back to initial state, replace again one A, then replace one B, like that you can do equal number of A, equal number of B. So, what is the concept here? See here, this is A X R, A X R. What we are doing? If your input is A in Q0, you replace to A by X and move right, Then after we have Q1. This Q1 state go to the new state. In Q1, when you will go to the B, what are the path in between, what you will get? So, let me do, then after that we will go to explain. See here, when you will go to the B input, in the middle you can find the A, because your string will be like this, A, suppose we will take an example of A, B, B or 3A, 3B. N is 3, then 3A, 3B will be generated. First one you have to replace X, then move to first B, then replace y. Again after replace y, then you have to take, this is right move, then you have to left move up to first x a, first a, then it will be x like that, then you have to go to the next b, next b replaced to y, like that we have to do. So, in the middle you have to, when you replace one a, in between you will find here a to a r, then y to y r. Why y to y r? A is there, why y to y r? Y to y r, because after replacing of one b, when you will go to the next b, you will find y in between x and b. So, here you check it, now this is okay, now this is completed. So, when you will find b from q1, when you will find b in q1, just replace b as a y, then move left, then after this is q2, in q2, when you have to go to the initial state q0, in again when you will back, when you will be back, then you have to this middle from y, you will come back to initial state. So, so here you will find here some b y to y l, some y will be there and some a will be there, a to a l. So, y a, then when x will come, when you will find x, then you go to the initial state, when x will be there, then x r. So, this is x r. Then after here, when you will not find any h, you have replaced all a to x, all b to y, just you have to go to the final state. In final state, here you will find here all x, when will be not there. So, you will find here after a is not there, then you will find here y, then y r, then here you have to make a loop, if more than many y will be there, y r, then this is blank and then blank, this is blank r, then this is q f, is the accepted state and you can say this is a q3. So, on this way you can convert this, you can make it equal number of a, equal number of b. So, take a string, suppose we have take a string here 2a to b and this is a tape. Now, you check it, this is a tape 2a to b we have taken, this is both side is blank. So, now q0 point to a, So, what will happen? This q0, a is replaced by the x, So, what will be there? Now, this is x and this is a, then b, then b, So, a is replaced by the x. Now, this is we have to move right, this is q1, move right. Now, you have q1 input is a. So, q1 input is a, what you have to do? Again this a will be remain same, I am not writing blank, this empty means you consider this is a blank. So, x and this is a and this is b and this is b and this is q1. Now, you check q1 to b, what you have to do? If q1 to b is there, what you have to do, replace b and write replace b by y, means you have to write y on the tape, write y on the tape, y on the tape. So, here x a and b, this is y and this is b. So, what you have to do, now you check, this is a left move, when replace b to y you have to take a left move. So, now your q 2 will be point left of y a. So, q 2 a, q 2 a. Now, you have q 2 a, q 2 a is there. What you have to do? Again you have to go left and go left, this is x, then a and this is y, then b. So, now q 2 point to x, because you have to move left, when q 2 a you keep a as on the tape and move left. So, q 2 x, q 2 x. Now, you check if q 2 x is there, what you have to do? It is q 2 x, means x will be there and move right. So, what will be there here? So, this is the way, this is x and this is a and this is y, then b, this is q 0, q 0. Now, q 0 point to a. So, I am writing here, you see q 0 point to a. So, what will be there? Again you have to replace x. So, I am writing here. So, q 0 point to a, then this is x, then x, then after replacing a to x, then it moved to right, this is y. Now, q 1 point to y, q 1 point to y, this is b. So, now you see in q 1 y, what will be there? If q 1 y, what again you have to move right. So, here you see here, this is x and this is x and this is b, this is x. So, now this is y, now this is b point q 1 point to b. When q 1 point to b, you check it, you have to replace it y and replace it y. Now, you check here, replace it y x, then x, then this is y and y and you move left, left moves, this is q 2, q 2. Now, q 1 b, we have to replace it y and move left. So, like that, then again q 2 y you have to move to, this is x, then y and this is q 2. When q 2 x, what you have to do? Q 2 x, then go to q 2 x, it will be go to q 0. This is x and this is x and this is y, this is y and this is y. So, now this is q 0, this is q 0, you can see this is a q 0 point. So, q 0 will be point to y. When q 0 point to y, we have to move the q 3 and q 3 all y will be there. Then after you have to go to the blank, then this is accepted. Then q 3, this all the q 0 to, you see q 0 to y. If q 0 to y, I am writing here q 0 to y, you see q 0 to y. What is the q 0 to y? When you will get q 0 to y, q 0 to y, see here q 0 to, this is x and this is y and this is y and this is q 0 to y, then you have to go to q 3, this is x and this is y and this is y, this is q 3 then after this is q3 x x y y, then this is q3 blank, now q3 point to blank, then after it will go to the final state. Now after that it will go to the qf final state, this is accepted. So like that we can have design this using contest using Turing machine, we can have design like that. So this is a contest free language, we can also have push down automata. So I will do more numerical, like you can do like context sensitive language. Suppose one example is there, you can say L is a to the power n, b to the power n and c to the power n, n is greater than equal to 1. So, this language is you cannot have push down automata, you definitely you have to go to the Turing machine, and this will be the at a time two comparison a to b, a to c. So, here also same concept, I already told you how to process the string, already you know. So, here you check it how to do this one. This x is replaced by a, y is replaced by b, y is replaced by b and z is replaced by c. So, here just I am doing the diagram. So, like that previous example, you can take a string in input tag and step by step you can process. I am doing the diagram. So, same process I am doing here, nothing more. So, q0, this is a, just I replace in first x, a to x. Then after we have q1, when you will go to the b, similar way you have to find here a to ar, then y to yr, then after this is b, b to yr, then here b will be replaced to y, then after we have q2, this z when it will be, then here what will be what will here you have to do, maybe b to br and z to zr and c to z left, c to z left, and this is the q3. So, what we did here, 1 a replaced to x, 1 b replaced to y, and when we will replace right move, in a you have to move right and b also you have move right, when we will replace c to z, 1 c replaced to z, then go left direction, then move left. So, here what you have to do, here you have to check it, all loop will be there in between this, when you will replace c to z, again you come back to q0, similar process 1a, 1b, 1c will be replaced. So, when you will come back to q0, what will be in between, you will find here z, z left, okay, then z left. So, then after here you will find here what is the b left, then y left, then a left. So, when x will be there, then go to the x will be there, then x r. So, this is the way you can have design this one, a to the power n, b to the power n, c to the power n. So, here you check, we remove a to x, then all a we move right, all y move right, then when you will find b, then 1 b will be replaced to y, then after you move right, then after when you will find first c, then replaced by the z, then left move, then q3 we have to come back to x. When we will come back to x, we will find here z, we will find here z a, here we will find here z a, z a b y, z a b y. Also we will find here c, you can find here, you see no, c will be not there, z will be there, z z l, b b l, y y l, a l. When x will be there, then move right direction. So now we have y to y r, then here z, then here y to y r, y to y r, then here you can say all z also move, all z, z to z r, then blank, this is blank to blank r, then go to final state q f, this is the final state. So you can say this is q4. So in this way you have to design the any context sensitive, not context free language, we have to go for the Turing machine and design like this. So here one question is given, so you check it, which of the following regular expression resemble in given diagram. So this is a very easy, you have to, you see here, here all the string, I think this is accepted by end with BAB. This is a regular language, you can say this is a regular language. We have see all right move, already I told you that when will be right move and read the input, nothing is changed, right move only, and in blank here hash is considered as a blank. So when we will take as a blank, then go to final state. So this is the question given and 4 option is given, you see here what string is accepted, who is regular expression will be there, and you see all the string, this is B, B A, A B A, A B A, see here A B A, all the string end with A B A, A B A, you check it, A then B then A, again it will go to the loop B, you see A B A, A B A. So you can say this is the right option, what is the A B A, A B A. So all the string end with A B A is accepted by this Turing machine. So you can say this is a regular language and regular expression is there, definitely we can have a regular expression for that. So this is the question, sometime this question came in competitive exam like that, some Turing machine is given, you have to find the language, and some language is given, some Turing machine will be there, and then who is Turing machine is fit for that. So there is MCQ question came in many times come in GATE exam. So these are references, thank you.